Hello, Devin Poe, 3i6 CIT 360. Here we go again. Sequence diagrams. Um, so first off, what are sequence diagrams? Um, they're yet another type of diagram, and sequence diagrams are a type of interaction diagram, which is used to show the interactive behavior of a system. More specifically, this diagram simply shows the interactions between objects in sequential order, hence the name. So, how do we make them? There's a couple different standards on them. The first standard is basically an actor, which is represented by a little stick figure. Glad it's not a hard symbol to draw that everyone can draw. Anyways, actors in the diagrams basically represent a type of, or it's a type of role that where it interacts with the system and objects. It's important to note here that the actor is always outside the scope of the system we aim to create with the model. We use actors to depict various roles, including human users and other external subjects, such as other programs that are trying to access us that are just outside of the scope of our program, or, whatever. Next, we have lifelines on the right here. A lifeline is a named element which depicts an individual participant in a sequence diagram. So basically, each instance in a sequence diagram is represented by a lifeline. Lifeline elements are located at the top in the sequence diagram. The standard in the UML for naming lifeline follows the following format, which is right down here, of instance class name, or instance name class name. We display the lifeline in a rectangle called the head with its name and type. So the difference basically between the actors and the lifelines is, well, very simply, in or outside and inside. That's not too hard to remember. So messages, there's two types, and then all other messages fall into these categories of these two types. There's synchronous messages. A synchronous message waits for a reply before the interaction can move forwards. The sender waits until the receiver has completed the processing of the message. The caller continues only when it knows that the receiver has processed the previous message, or when it's received its reply, and a large number of calls in object-oriented programming are synchronous. Asynchronous, however, it's a message that does not wait for a reply from the receiver. The interaction moves forwards irrespective of the receiver processing the previous message or not. So these are generally things like welcome screens and things such as that. Or, even just if you want logging, logging can be a type of message, whether it logs something that was an error or correct. It logs it no matter what happened to it. It didn't care what happened afterwards. Delete message. This one's represented by a X with an arrow pointing to it, and a delete object is when an object is deallocated memory or is destroyed within the system. We use the delete message symbol. It destroys an occurrence of the object in the system. So basically it just gets rid of that occurrence. We have reply messages. Reply messages are used to show the messaging being sent from the receiver to the sender, and we represent a return reply message using an open arrowhead with a dotted line. The interaction moves forwards only when a reply message is sent by the receiver. Then we have a found message, which is a big, dot with an arrow coming out of it. And the found messages are used to represent a scenario where unknown sources send messages, or when an unknown source sends a message. Sorry. It is represented using an arrow. Oh, I already talked about that. And a lost message is the same, or is similar to a found message, just reversed. I mean, in how they're drawn. The arrow is pointing to the actual endpoint. And a lost message is used to represent a scenario where a recipient is not known to the system. It is represented by using an arrow directed towards the endpoint from a lifeline. Next we have guards. And to model conditions, we use guards in UML. They are used when we need to restrict the flow of messages on the pretext of a condition being met. Guards play an important role in letting software developers know the constraints attached to a system or a particular process. For example, in order to be being able to withdraw cash, having a balance greater than 0 is a condition that must be met as shown, or that must be met. And they're represented as I have right here. So I have it can be a circle, it can be a square, with rounded corners. I found that they use both of them. So here's an overall example of a UML sequence diagram. You have the user, which is in this case inside the scope of our program, but he goes and he opens the application, and it comes back, and in this case the webcam sends a message to access itself. So it just basically, it doesn't need to wait for a reply to access the webcam. It just opens up itself. Then you can get the photo, and you can detect the face, which this is what the device is doing, and then it sends a message to display the mood. Now the mood can go to the database and be retrieved music or a generated playlist, and the playlist obviously comes from the device going back to the user. So yeah, that's just a really simple one for it. It is an example one that I found on the internet, so it's not like my original creation. I want you to know that, but I mean, I could make one if you wanted me to make one. It's not too terribly complicated, but I felt like this was a good representation of like what one does, or what a sequence diagram is. Anyways, thank you so much for your time, and you have a great day.